Hi, in this video, we are going to continue on Unit 6, Periodic Table. And in this video, we have two agenda. First of all, we are going to look into some past paper question concerning about the chemistry of group 1 metal. And after that, I'm going to show you a demonstration of the experiment called jumping metal experiment. And after the demonstration, we are going to jot down some remarks on our notes. Now let's get started. Now, first of all, this past paper set, you can actually find it from the link under the description of this video. It would be best if you can download it and print it out. So again, it would be best if you can pause the video and go through this question yourself first before actually looking at my answers. So let's get started. First of all, this question concerns about three metals, and these are all group 1 metals. Now remember, in the exam, you are not given with the periodic table. So it will be best for group 1, group 2, group 7, group 0. At least you need to be familiar with the first three members. So in this case, you should know that lithium is the first member, followed by sodium, and then potassium. So potassium is the third member. Now cesium, even though you don't know whether it is like on the period 5, period 6, or period 7, but all you know is cesium should be a member of group 1 metal under potassium. Okay? Also, you need to know that for group 1 metal, the reactivity increases down the group, meaning that lithium being the first member is the least reactive. Potassium must be more reactive than lithium, and cesium should be the most reactive among these three metals. Okay? Now, this table shows you the observation when these metals are allowed to react with water. And the first one here, you see it explodes on contact with water. So this is a very vigorous description of an observation that is probably for the one that is the most reactive. So here, the second one, fizz gently. So it is a very mild observation, probably for the weakest, the least reactive metal. And the third one here reacts violently to form a lilac flame. Now this word gives you huge hint because lilac flame hints towards the presence of potassium. So you can tell actually this one is potassium. Okay, and then the one that reacts the most vigorously has to be cesium, and the one that reacts the least vigorously has to be lithium. Okay, now down here, B1, give the name and formula of the gas formed when potassium reacts with water. Now for group 1 metal, when they react with water, they give two different products. That includes a metal hydroxide as well as the hydrogen gas. So in this case, it is referring to the hydrogen gas. And the chemical formula for hydrogen is not H, but it should be H2. Okay? Now you will expect to have question asking you about the chemical formula of some simple common chemicals. Like hydrogen, you need to know it is H2, not just H. Alright? Now B2 here, give the name of the compound formed when lithium reacts with water. So lithium reacts similarly as potassium, forming metal hydroxide and hydrogen gas. In this case, the metal hydroxide has to be lithium hydroxide. Okay, that's the idea. Now, next page. We still have a follow-up question. So B3 here, describe how you could show an alkaline solution is formed when cesium reacts with water. So how can you prove that the resulting solution is alkaline? Now, of course, you will be making use of an indicator. Okay, and there are a lot of choice. You can choose a universal indicator, you can choose litmus paper, you can use a pH paper, or even a pH meter. So there are a lot of choices. So I will use the one that I have mentioned in my notes. So you can put down, add a few drops of universal indicator. Okay. Now then that would be one mark because you talk about an appropriate method. And the second mark goes to the expected observation. Then you will put down the solution changes from colorless to blue. Okay, the solution changes from colorless to blue. Okay. All right. You can also use a red litmus paper, and the red litmus paper turns from red to blue. All right. You can use a pH paper, so the pH paper changes from yellow to blue. You can use a pH meter, then the pH meter gives you a pH greater than 7. Okay, so these are all the appropriate answers. Now let's move on to question 2 here. So it's a multiple choice question related to the group 1 elements. So which one is related to lithium is correct description. Um, First of all, it has to do with the electrical conductivity. So even though you know group 1 metal exhibit quite a different physical property when compared to general metals, when it comes to electrical conductivity, it is still a good conductor of electricity. So in this case, we are going to choose A or C. Okay, they are good conductors. And then the second part has to do with the chemistry with water. So obviously it forms an alkaline solution rather than acidic solution. So in this case, we will definitely choose C. Okay. Now B1. So a piece of sodium is added into large trough of water. State 2 observations that could be made. We have a lot of choices. In my notes, I have like up to 4 observations, so you can just choose 2 of them. You can put down the grayish solid melts into a silvery ball. All right. And you can also mention that the solid travels rapidly on water surface, producing hissing sound. Okay. You can also mention about sodium catch on fire and burns with golden yellow flame. Okay. State the word equation for the reaction involved. So you can put down sodium reacts with water to form sodium hydroxide as well as hydrogen. Okay, sodium reacts with water to form sodium hydroxide and hydrogen. Okay. Part C. Potassium reacts in a similar way as sodium. Yes, we can predict it. It's more reactive because it's lower down the group. Now, state one observation that could only be made when potassium is added into water, but not with sodium. So the only observation that could be observed when it comes to potassium and water has to be the lilac flame, the characteristic lilac flame. So we will put down here only potassium burns with lilac flame. Okay, so that should do it. Now part D, explain why elements in group 1 have similar reactions. Now, in this question, you have to think about what determines the chemical properties of an element. And you should recall that the electronic arrangement determines the chemical properties of an element. So in this case, elements in group 1, they all have one outermost shell electrons, so that their electronic arrangements are very similar. So that accounts for the similar chemical properties and similar chemical reactions. So here, what you're going to put down here is, you're going to put down they all have one outermost shell electrons. So they have similar electronic arrangement. Okay? So they all have one outermost shell electron, therefore they all have similar electronic arrangements. Okay? So that would be all the past paper questions here. Now you can see that a lot of this question has to do with the observation, as well as a lot of question concerns about the difference in reactivity along the group 1 metals. Okay? Now these questions, to be honest, is quite simple because they are not from CE, not from DSE, not from A level. These questions serves as some kind of a revision on the basic knowledge, basic concept. In the real exam, you will expect to see questions to be a little bit more difficult. Okay. Now, that's it for the past paper. Let's move on to the experimental demonstration. Alright, so now I'm going to show you the jumping metal experiment. So first of all, we are going to prepare a small cube of sodium metal. After that, we are going to half-fill a large measuring cylinder with tap water. To that, we are going to add a few drops of phenolphthalein. Now, we are going to add paraffin oil to the top of the water. Now, as you can see that there are two immiscible layers of liquid. Of course, the upper layer is the paraffin oil and the lower layer is the tap water together with a few drops of phenolphthalein. Now, we are going to add these small pieces of sodium metal from the top. And let's observe. Now, as you can see that the metal jumps up and down as we introduce the metal. Now, first of all, the reason why the metal sinks in the paraffin oil is because the sodium metal is denser than paraffin oil. Plus, there is no reaction between sodium and paraffin oil. So that's why at the beginning it sinks. Now, when the sodium metal reaches the water layer, then the sodium reacts with the water to form sodium hydroxide and hydrogen gas. Now, the hydrogen gas will form and exist as colorless bubble, and the hydrogen gas bubble will push the sodium metal upwards. So that's why the metal jumps up. But once the sodium travels to the top and the hydrogen bubbles are all dissipated, are all gone, then the sodium metal, being denser than the paraffin oil, will again sink to the bottom, where it again touches the water, and this cycle repeats. Now, you also notice a very distinctive color change in the water layer. So the solution changes from colorless to red or colorless to pink. The reason is because the reaction between sodium and water also produces sodium hydroxide. And sodium hydroxide dissolves in water to form an alkaline solution, and therefore turning the color of the phenolphthalein from colorless to red or purple. Okay, so after watching the demonstration, let's fill in some blanks on our note, page 39. 39. So here, this shows you the jumping metal experiment, and again, the top layer is the paraffin oil, the bottom layer is the water. And here, the water is mixed with a few drops of phenolphthalein in the beginning. Now, at the beginning, remember the color of the water before we drop in the sodium should be colorless, okay? And when the reaction has taken place between the sodium and water, then it turns red or pink or purple, okay? Now, first of all, we need to make sure we know the difference in density. So the one that has the lowest density must be the paraffin oil, okay? So you should put down paraffin oil has the lowest density, okay? And then the one that has a higher density than paraffin oil would be sodium. And the one that is having the highest density must be water, okay? Now, sodium, what's in the paraffin layer, because sodium is denser than paraffin oil. So this one you should put down sinks, right? It sinks. Okay, so that's why when you put the sodium here, it kind of sinks to the bottom because sodium is denser than paraffin oil. And also because the sodium does not react with the paraffin oil. Because if the sodium reacts with paraffin oil, I don't think the sodium will sink. Okay, because they keep making those bubbles, and that would always be propelling it out upwards. But anyway, knowing that sodium is not going to react with the paraffin oil. Now, once the sodium touches the water layer, it reacts with something to give two different products. So it reacts with, of course, the water to give hydrogen, as well as, because it's a sodium, so we have sodium hydroxide. Okay? All right, so the word equation, basically you put down sodium reacts with water to form sodium hydroxide and hydrogen gas. Okay? You can copy this one from the table on the left hand side. Okay, so the third sentence here, hydrogen gas bubble push the sodium metal up. Now this is very important because if you are asked to explain why the sodium goes up and down, then you must tell me that it is the hydrogen gas bubble that pushes the sodium metal up. Okay? And once the metal reaches the top and the bubble are dissipated, then the sodium sinks again. Okay? Now, you also want to mention about the color change. So sodium hydroxide is something which turns phenolphthalein from colorless to purple to red. So here, sodium hydroxide is alkaline. Okay, it's alkaline. So that's why it can turn the phenolphthalein from colorless to purple or red. Okay. Now, remarks here for phenolphthalein. So the phenolphthalein is actually an acid alkaline indicator, and this guy, when the pH is lower than 8.3, then it would be colorless, and when the pH is greater than 8.3, then it would be purple or red. Alright, so in other words, when the solution is acidic or kind of neutral, then it will be colorless. But when the solution is alkaline, then it will become purple or red. Alright, for the details of this indicator, we will actually talk about it in Form 4. Okay, so that's it for the video.